Okay. Next up on the stage, we have an ex-Ethereum Foundation grantee, a graduate of StarkNet's Hacker House program, and now the founder and ecosystem lead of Kakarot. Please welcome to the stage, Danilo. Give him a warm round of applause, guys.
Hello. Oops, yes. So who here have already heard about Kakarot before? Okay, nice. Maybe by the end of it, everyone will know more about Kakarot. First of all, I would like to thank Abdel, because Kakarot wouldn't be here without his push and his initiative on trying to really push the open source community, and hope Kakarot can deliver up to his expectations. So, as mentioned, Kakarot is a EVM written in Cairo, which means that everything we execute can now generate traces that can generate Stark proofs. And at first, we just started as, okay, this might be fun, why not do it? And in the beginning, we had a lot of possibilities because Cairo can be used for both off-chain execution and as a smart contract. And we had the EVM implemented in Cairo, and then we could choose like which path we could go. We could be deployed on StarkNet, or we could be on L3, on L2. Last year, we decided that the first delivery of Kakarot will be an L2 ZK EVM. And as aligned with StarkNet, our goal is to scale Ethereum and also bring extra features beyond just scalability, which is better UX, native account abstraction, and so on. So before, like, how can we build a ZK VM? Basically, there are the two main ways today, which is you can write EVM circuits and compile to Snark, which is most of the other solutions like Scroll, Polygon ZK VM, ZK Sync. ZK Sync is not exactly like this, but Polygon and Scroll is. And in the case of Kakarot, we are using Cairo, which compiles to the Cairo VM and then generates traces that can be proved by Starks. So you can see that there's a bit of overhead. Like we are building a VM on top of another VM. So we can expect some overheads, but why do we believe that Kakarot is compatible even though there is some overhead? And there are three main things. The first one is speed of development. Kakarot, today, we are a team of 6, and in just 1 year, we have written not only one, but 2 full ZK VMs. One in Cairo 0, and another one in Cairo 1. And comparing to like how long all the other teams took and how much investment they needed to deploy, I think like time is in our favor. The second thing is adaptability. Because it's a lot easier to maintain and put out code or change code in Cairo than in pure circuits, it's a lot easier for Kakarot to adapt to the constant changes for Ethereum. Ethereum now is changing. I think it has major changes once every 2 years, and Kakarot should be one of the fastest that will get up to date, especially because we are aiming to be fully Ethereum compatible. And I think that's going to catch up. One example is that on Denkun, Kakarot will be ready, fully Denkun compatible. So we started working on Denkun about a few weeks ago, and we plan to, in 2 weeks, to be already fully Denkun compatible from day 0. And besides adaptability and speed of development, I guess security is another aspect because a lot of projects are using Cairo, so the Cairo VM is being audited heavily and being tested, not by only Kakarot, but by other projects that are using Cairo. And in our case, so we have the security from Cairo, and we are auditing Cairo code base is easier than auditing pure circuits. So we have these 2 advantages. 1, that Cairo is easier to audit, and 2, that because there are a lot of projects already using Cairo, like there's more stress tests in Cairo compared to other ZK VM circuits. This is just a graph of some trade-off. For example, in the left is adaptability, which basically, because Kakarot is a higher level language, our adaptability is higher, but because we have some overhead, we can say that our performance is lacking a little bit from the other options. An example would be if you write a program in assembly versus in Python. There is some overhead, but with all the improvements from the Cairo, from Starks, and from the Starkware ecosystem, we believe that we will be able to catch up on speed and also cost of generating proofs. And this is just a post from when Kakarot was starting, actually. There was people mentioning, like, oh, how can be this simplified? Like, the code for the PSC is the Privacy Scaling Exploration, is the ZK team from Ethereum Foundation. They have like almost 35,000 lines of code. And even Vitalik mentioned, like, a higher level language might be more sustainable on the long run because of speed, adaptability, and each year, every time ZK becomes more efficient, the gap between the overhead between Cairo and pure circuits starts to get lower and lower. And this is an architecture of Kakarot. So basically, how does Kakarot works? Let's start with the user. So the user sends a transaction, and then we have a Kakarot it RPC. This RPC sends a transaction to a StarkNet node. Because Kakarot, we are basically using the StarkNet stack. For example, we can use Madara or an app chain, and we deploy the Kakarot contract on top of it. And then there's the StarkNet RPC. The StarkNet RPC receives. We have EOAs that are basically implementation of an EOA from the account abstraction from the StarkNet. This EOA receives the transactions, validates the signature, sends to the Kakarot core EVM contract. You can see it as a smart contract, which you interact with the state, execute the opcodes and everything, and then store the states. These states down there are the same states that are on the StarkNet stack. So we're using the same transactions type, receipts, blocker heads, logs, and basically what is happening is that, so then how can Kakarot be compatible with all the EVM toolings? Is this it RPC. On the it RPC, we are like bridging, like we're transforming StarkNet answers and calls into it answers and calls. And after that, we send all the traces to the StarkNet share prover, sharp, and then it's settled on Ethereum L1. So, okay, in which stage are we right now? We started as an open source project in October 2022. By December, we had all the opcodes implemented. And after a few more weeks, we had a first version of 8 of 9 precompiles implemented. Not, like a lot of them, we are revising, and then we are fixing a lot of them. But like we already had like something working. And actually, like in January 2023, we could already execute Uniswap transactions. But like most open source projects, like we weren't production ready. So the next step was to, okay, how can we take this one step further and bring this to production? That's when we decided to incubate Kakarot so we can have like full-time people working on it. And so what we did is we integrated Kakarot with the Ethereum Foundation tests. Ethereum Foundation have 20,000 plus tests to make sure that all the EVM implementations are aligned. Because we have get, ret, zeth, like Ethereum in JavaScript. Because there's so many implementations, like Ethereum Foundation had have this test that makes sure that if you pass all these tests, you can say that you are compatible with the EVM that we expect you to have. So right now, we are passing 90% of the Ethereum Foundation tests. Just for context, some major L2 ZK VMs don't even run the tests, and some of them who does passes 14,000. They say the rest is not important, but in our case, we want to pass all the tests so that we can, for sure, say it's not a discussion between who is more aligned and who is not. We are aligned, and they cannot be more aligned than passing 100%. So right now, we are already running a closed testnet with the Starkware team. We are using the StarkNet app chain solution because it has been beta tested, and it was the fastest option for us to start testing in production. We are also working closely with the Madara team. But because it hasn't been tested in production, we decided to start with this route. And right now, we have more than 20 projects interested in deploying Kakarot. We have Frax Finance, Impossible Finance, Pancake Swap, LogX, MetaVault, Fetch, MyFinance, and many more. We see a lot of interest from DeFi and gaming. So we are very excited to be showing up what we have been building in the last 2 years soon. So what is next? Our next step will be we're going to release a closed beta testnet, which will be invite only. So right now we are testing only internally. We are running some extra tests. We haven't opened up for the projects yet. The projects are waiting, every day messaging us to when. We are going to open up for them first. We are onboarding the first Core Stars users from the StarkNet Core Stars community to just purely test, and then we will start rolling out invitation applications for more and more people. And by April, we expect to have a fully public testnet when anyone can join, can test it out, and mainnet, which will depend on how the testnet goes, what we want to improve, what we would like to change, and so on. Another thing that we are currently working on is something called Mobile Stack. AA is very powerful on StarkNet, and we believe that we could bring these powerful use cases to the EVM space as well. So we are researching and working on a framework that will allow simple mobile signature multi-calls and paymasters and a lot of the things that can help UX, because we believe that the next step, like besides technological improvement, UX improvement is one of the biggest pillars in Web3, and we aim to incubate the projects that has the least resistant path for new users. What I mean by least resistant path is we want any user to be able to use dApps in Kakarot in less than 5 minutes, even though they have never used Web2. We are already in talk with some projects that are doing amazing things, and we hope to be able to showcase them very soon. And yeah, that's it. Follow us on Kakarot ZKVM. If you are a project and would like to partner and try out our testnet, feel free to reach out. You can also reach out on my DMs. If you are a user, if you're here, I believe like you are part of the StarkNet community, and we would love to also give you access to the closed beta testnet. So thank you.